Hey everyone, we are going to move on to the other trig ratios. And the thing that I like about trig is that once you understand what sine and cosine differentiate into, you just apply those rules to other trig ratios, and you can come up with 6 more rules or 8 more rules or 10 more rules. So an example is what's the derivative of tangent? How do you find the slope of a tangent curve? Well, we use what we know from our previous math is that tangent is sine over cosine, recognized as a quotient rule, and you run through the quotient rule, and you see if you took the derivative of this quotient, sine x over cos x, you get 1 over cos squared, which means if you started with tangent and you took the derivative of tangent, your answer is 1 over cos squared x. And because we don't like working with fractions, we say the derivative of tangent x is secant x squared. All right, so that's the idea. We can apply that kind of rule to everything that you know. You want to find the derivative of secant. Secant is cos of the function to -1. Use the chain rule, expand, simplify, and you see if you started with secant x, its derivative is tan x secant x. If you started with, what's the next one? If you started with cosecant, cosecant is the sine reciprocal. So again, drop it by a degree, multiply through, derivative of sine is cosine, simplify. So your derivative of cosecant is negative cotangent cosecant. So if you look at a formula sheet that we have for our trig, you're given these identities. You don't have to memorize these in Math 31. If you move on to like a university calculus class, though, they'll expect you to memorize these. How do you find the slope of cotangent? You can go through the whole process of cosine divided by sine, or again, just go down to the rule. So you don't have to derive these every time. Once you know the derivative of cotangent is negative cosecant squared x, you just get to use it. So trig is awesome. I think trig is awesome because we just get to add some layers to our questions and keep on applying the rules, applying product rules. So x squared times tan x is product rule. You've got a sum rule. Farther on down here, you'd have a quotient rule. Here's a power rule, tan of 2x to the half. I got 3 colors here because there's 3 rules. You got the exponent of a half rule happening. You got the tangent rule happening. You get the 2x rule happening. All right, so trig, it just has layers. It's got the onion. It's Shrek math, right? So you just kind of make sure you apply every layer, right? So exponent of a half has a rule. Tangent has a rule. Secant has, sorry, I did that backwards. The half is in red. Derivative of tangent is secant squared, and then the 2x becomes the 2. All right, so watch your layers. Don't get too excited about how much fun these trig questions are. Quotient rules. Tan of x plus 1. You could do as a quotient, but I would prefer not to because derivative of your numerator is 0. So to me, this is far better off being written as an exponent of -1. -1 goes in front, drop by a degree. Derivative of tan x plus 1 is secant squared, right? So just lots and lots and lots of layers. Secant, derivative of secant is secant theta, tan theta. So secant x squared plus 1, tan x squared plus 1, that's the rule. And then what's the chain rule is what's the derivative of x squared plus 1, 2x. Okay, so lots of great questions. Derivative of cotangent is negative cosecant squared. The root x doesn't change, but what is the derivative of root x? Half x to the -1/2. Clean it up. All right, so we got tons of things happening here. I like this question as well. 2 cosecant 3x. 2 is nothing, it's just a stretch. Cosecant has a derivative, 3x has a derivative. All right, so you got 2 different things to work with there, and then of course you simplify. Talk about layers in a question. You got a 2, which does nothing. You got secant, which has a derivative. You have 2x cubed, which has a derivative, and you have a power of 2, which has a derivative. So again, when you go through your layers, 2 times 2 is 4. Nothing changes in the original brackets. That's your black layer, went down to an exponent of 1. Your blue layer, what's the derivative of secant? Derivative of secant theta is secant theta, tan theta. Whatever's your theta doesn't change. The third layer is what's the derivative of the 2x cubed? It is 6x squared. All right, so watch your layers. Like I said, have some fun. And if you know how to do asymptotes in previous chapter, curve sketching, you can do asymptotes anywhere. Vertical asymptotes are what's causing divided by 0. So this is like a Math 30 question. You just kind of change things so you get denominators. So you have divided by 0 when cosine is 0, and from negative pi over 2 to pi over 2. And again, cosine is adjacent over hypotenuse. So when is it that you have 0 for cosine? You have 0 at pi over 2 and negative pi over 2. So you've got your asymptotes. All right, so I mean, this lesson, it's really just a matter of seeing the layers and working through the layers. So have some fun with it. Enjoy these questions. And I would encourage you to kind of go to the website and make sure that you know how to do the first couple of trig homework questions too this week. So, all right. Hey, have a great week. Enjoy the trig. Talk to you soon.